Hi, welcome back to working with exponents. Today we're going to work with division properties of the exponents. So let's put your name at the top of the paper so we can keep your materials to you. All right, so what we see as we get started working in these problems is the division rule. And this division rule tells us that you can, when you're dividing a base, divided by same base with a different exponent. And mind you, this can be written either out horizontally or vertically as a fraction. What you end up doing with your exponents is you end up subtracting them. So this is a to the m minus n. That is the rule that we are going to put into place again and again through these problems. So there are a couple ways that you could do this, but some of them move a lot faster than others. And if we have the opportunity to do less work with fair rules, not abusing any rules, and move faster, that usually is the preferred way to go. So let's look at method one. Method one is asking us to divide. We're going to evaluate and then divide the results. So what is 6 to the 6th power divided by 6 to the 4th power? Well, in your calculator, you can do this. You can say 6 to the 6th. Do you know how to put that into your calculator? I'll tell you real quick. You put 6, that's your base, and then you would push the caret button. This is the caret. I do not know why it is called a caret. I just know that it is. And depending on the calculator that you have, it might just leave this symbol on the screen, or it might create a little text box that's in the exponent location. Either way, we'll finish off with our 6 to the 6th power, and you should get 46,656. That is a lot. And then you would do the same thing here with 6 to the 4th power, and you can practice this with the caret. And you should get 1,296. And then we're finally going to do as the problem asked us to do, which was to divide the two quantities, and we find out that it's 36. The end. All of that, all of these giant numbers, just to say 36. Okay, well, let's see if there's a faster way, maybe an easier way to get this done. So method 2 would be, all right, well, let's expand it. 6 to the 6th power is really 6 sixes all multiplied together. And 6 to the 4th power is really 4 sixes all multiplied together. And remember, if you have something that's exactly the same on both the numerator and the denominator of a fraction, you can cross them out. So what's left? Oh, 6 times 6, which is also 6 squared. Either way, we know that 6 times 6 and 6 squared both make 36. I think that was a lot easier to get this problem done with less work, less having to strain our brains. So let's see if the rule now comes into play that we said at the top of the paper. We said that you could subtract your exponents as long as the base is the same. And 6 minus 4, yeah, that's 2. And 6 squared, that is 36, which is the same answer that we've gotten every time that we've done this problem. That was super fast. The least amount of work, the least amount of brain strain, that is the preferred method. But if you don't remember the rule, you can always expand it out That's one way. Or you could go old school. You could find out what it really makes and then work it out with your calculator. All three of those methods get you to the same place. And it's just a matter of using the one that works the best for you and your time most efficiently. All right, let's look at another one. So that was using just hard numbers, concrete numbers. What about variables? What about using x's? All right, well, we're going to show that the division property of exponents to create x squared can be x to the fifth divided by x to the third, as long as x is not equal to 0. Have you ever asked Siri what 0 divided by 0 is? That's pretty entertaining. It doesn't work. So that's why we have to say x cannot be equal to 0. All right, so we took our original problem, x to the fifth divided by x to the third. We expanded them out. You can cancel out everything that is on both the top and the bottom. And what remains? Oh, just x squared, because it's 2 x's. It worked. Exactly what we wanted to see from our original problem. Okay? So we're also going to see that again. It's shown again, whoops, right here with I could have subtracted the exponents instead of expanding them, expanding the x's and then crossing them out. Either way, totally works. So let's turn the page and do some problems together. Problem number 1. 7 to the fifth power divided by 7 squared. Let's look at it both ways just to make sure we have a good understanding of what's going on. There are 5 7s in the numerator. 1, 2, 3, 4, 5. Oh, that's it. Haha. I was getting a little carried away with my 7s, wasn't I? There we go. And on the denominator, I have 2 of them. That's it. So these cancel out. And how many 7s do you have remaining? 7 to the third. So now let's make sure that we can apply our rule and get to the same place. So our rule says subtract the exponents. 7 to the fifth minus 2. Well, that's 7 cubed. Even less work. That's fabulous. And then depending on the instructions given to you, sometimes they're going to want to know what that is fully expanded. Break out your calculator. Always go to a new document. Never save. I just need a straight up calculator. So 7, find your caret button, cubed. 343. 434. What am I doing? No. It's a crazy day. Crazy day. I'm reversing numbers and putting in too many numbers. Extra human today. There you go. Okay. Good deal. Let's do number 3. So problem number 3. This has 5 squared divided by 5. How many 5s is this? What is the exponent if 1 doesn't show on there? I kind of said it, didn't I? It's just 1. So if you wanted to expand it, you'd say 5 times 5 divided by 5. Yeah, it's just 5. Like, done. 5. Or you could use the division, the quotient rule. So 5 squared minus 1 is just 5 to the 1, or just 5. Good job. Let's check out number 5. Got a lot of 5s. Okay, in this problem, we have exponents that are fractions. Does that change the rules? No. It just doesn't let you write it out as in the expanded form. So by this point, I need you to know the rule and use the rule, which says subtract your exponents. So m to the 3/4 minus that 1/2. And if you're not confident with your fractions and you have an Nspire calculator, you can put it in here. So let's remember how to get up the fractions on your screen. Control divide. 3, arrow down, 4. There you go. Now arrow to the right so you have a full-size blinker, minus, let's get another fraction. Control divide. 1, arrow down, 2. Okay, I have 3/4 minus 1/2. What do we get? Push enter. 1/4. Fabulous. So this is m to the 1/4. There you go. That was pretty easy. Especially if you were concerned about your fractions, it is great to know that that calculator can help you so much. All right, I want you to do number 7, and we'll check to see if we got the same thing. I'll wait for you. What did you put for your exponents? 3 minus 1? Great, because there's an exponent of 1 on the denominator. If nothing is showing, there's a 1 there. So your final answer? You got r squared? Perfect. Nice job. Okay, go try number 9 and see if you can do a throwback to our lesson the other day in working with reciprocals, hint, hint, for negative exponents. See what you get. Did you say 3 minus 5 for your exponents? I hope so. Does that make positive 2 or negative 2? Negative 2. That's true. So if we had instructions telling us to write our answer using all positive exponents, how did we write this the other day? Take the reciprocal of your base and then square it. Good job. Okay. Let's go look at problem number 12 together. We are going to compare multiplying and dividing powers with the same base. I wanted to do this one with you just so you could get a nice visual of how they're related, how you can show the work, in case you don't remember the rule, to get yourself back to the rule. So if we had, if I had a to the 5th power times a to the 3rd power, I'm making that up, and I wanted to expand it so I could see it, I'd say, all right, that's 5 a's. 1, 2, 3, 4, 5. Times a cubed. So there's 3 more of them. And you might say, well, you've got parentheses there. Does that really do anything? Well, they're multiplying. Parentheses are multiplying, and all of these a's are multiplying. Yeah, they're all just strung together, multiplying. So how many a's do I have? Count them up. That's right. a to the 8th power. And what did our rule tell us to do anyways? Said to add the exponents. 5 and 3, which makes 8. So that's the multiplying rule. You add the exponents. And let's look at what the dividing rule does again really quickly. We'll use the same variable, the same exponents. And we'll expand it again. 1, 2, 3, 4, 5. 1, 2, 3. And just like we did earlier in the lesson, you can cancel terms out that are on the numerator and the denominator. And what's left? A times A. What is A times A? A squared. And the rule said that we could have gotten that by just subtracting our exponents. So those are my thoughts on comparing the multiplying and the dividing powers with the same base. Your job is to finish this handout 2 through 11, and let me know if you get stuck.